Okay, hi everyone. So today we are going to discuss a bit about free body diagram. From your tutorial on Monday or Wednesday, you are given 6 free body diagrams to try and draw. So today we'll discuss the 6 free body diagrams that you are given to draw. So if you look over here, the free body diagram usually in chapter 4 you usually have 5 things. You go for the weight, then you see whether there's any cables or not, then there will be tension. Then you go for whether there's any force being explicitly stated, that's external force. Then you move on to whether there's any surface in contact, that's normal force. And lastly, if the surface in contact is rough, most probably there will be static friction or kinetic friction. 5 types of forces. But here in chapter 8, things get a bit complicated. It's still the same physics, okay? The physics don't change. Just that there are certain things that get a bit complicated. Okay, let's look here. So there are 5 types of forces that you need to identify. The first thing is still weight. Second thing is still tension. Third thing is still external force. Nothing much changes. Fourth is usually normal when we are doing chapter 4, but we do friction first, no worries. Then the last thing is a bit special. Last thing usually is normal force, but now I call it reaction force. It's normal force last time. Okay, so now it's reaction force. It's not that we change normal force to become reaction force. It's just that reaction force is actually just a collection of normal force. Okay, let's say if I have an object, then I pacha it like this, then there will be pacha it like this, like you have a hinge holding it. Then the normal force will be quite complicated. Then it's very difficult to tell you how the normal force is pointing. Because normal force we usually say is perpendicular to the surface, right? But here it's very difficult to identify. Actually, there are multiple normal force adding up together, but it's difficult to identify. So we just call it reaction force. It's the reaction force because this object is touching a hinge or touching a certain pivot. Okay, so that's the idea behind reaction force. It is still normal force, just that it's a more complicated combination of normal force. Since it's too complicated, we just use a single force that we call it as reaction force. Okay, so let's move to the first question and see. So this is the first question that you are given. So if you are drawing a free body diagram, the first thing that you need to do is to identify the object. Last time the object we represent it by a dot. This one we represent it by a rough idea, a rough simple 2D shape of the object. So it's quite clear here we are more interested with the wooden plank rather than the person. So this is the object of interest for us. Okay, so if this is the object of interest, then when we draw it, we represent it by a simple line. Don't get too complicated with the drawing, just a simple line will do. Okay, don't need to make it a square, don't need to make it a rectangle, don't need to get fancy with it. Okay, so after drawing the object, last time it was a dot, now it's a rough idea, a rough 2D shape of the object. We ask ourselves the same 5 questions. First thing, does the object has mass or not? Well, you know it's a wooden plank, there will be mass. Okay, so you might be thinking, where should the mass come out from? Last time it was just a dot, it's easy coming out from a dot. But now it's a horizontal wooden plank, so where should it come out from? So the idea is like this. If you have a plank and they tell you that it's a uniform rigid body, uniform rigid body means by the mass here and 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 the mass here are the same. It's uniform. It's not concentrated on one side. Concentrated on one side means by this side very heavy, but this side very light. That one is not uniform. usually in our syllabus things we call it uniform rigid body. So if it's uniform rigid body, the mass is evenly distributed. If it's evenly distributed, then the center of mass will be at the center. Okay, if you remember, weight is just gravitational force. So if it's gravitational force, you know that gravitational force acts along the line that connects two center of mass. The first center of mass is here. The second center of mass is the center of Earth. So it's pointing directly downwards from the center of the object. Okay, so in this case, this will be my weight. Okay, since there are two objects here, I might be more specific. This is the weight of the wooden plank. Okay, after solving the first thing, this is object. Our object has mass, therefore you have weight. Second thing, any ropes, any cables, any specific like cable strings, no. Next thing, any force being explicitly stated, and I believe the answer is no as well. They don't specify, they didn't draw any F here. So fourth thing is whether there's friction. Okay, we base it on the previous diagram, whether there's any friction or not. In this case, there's no friction. I mean, the friction is irrelevant here. So the fifth case will be the reaction force. So reaction force is normal force plus many other kind. When you have hinge, when you have pivot, then that's reaction force. So you can see here that there's contact here and there's contact here. So these 2 points you have reaction force. So for this point here, it's just a wooden plank with a triangle. So if it's a point and a dot, the force will be just perpendicular to the surface. So the force will just be perpendicular to the surface, so it probably looks something like this. So now my question to you is whether it's pushing up or pushing down. Well, the triangle is here to prevent the wooden plank from going down. It's pushing it upwards. Only if the wooden plank will fall down. That's why the normal force should be pointing upwards. Since it's a very direct reaction force, it's just a normal force pointing upwards, we don't need to call it reaction force. So we can just call it normal force. Okay, so let me do a bit of modification. So it's not downward, it's upward, and you label it as normal force. Then, is there any other surface in contact? Yes, we still have this one. This one, it's quite clear that your shoe and the wooden plank, so the direction will be somewhere around here. So your foot is stepping on the wooden plank. Stepping on the wooden plank means that you are pushing the wooden plank downwards. That's why the normal force will be pointing downwards as well. This is a normal force due to the person. This is a normal force due to the pivot. Now, you might be thinking, my free body diagram doesn't look like this. I write this as the weight of the person instead. Okay, so actually, we usually just write weight of the person. So why is it we can just straight away write weight of the person? It's because if you draw the free body diagram of the person has weight, and at the same time, because it is in contact with the wooden plank, that's why there's normal of the person. Okay, this is the FBD for the wooden plank. This is the one down there is FBD for the human person. And since we know everything is not moving, everything is in equilibrium, so sum of Fy is equals to 0 for the person. if sum of Fy is equal to 0, then the normal of the person minus the weight of the person will just equals to 0. That's why the normal of the person is the weight of the person. So you don't need to write both of this. This is just telling you that this thing and this thing, they are equal. That's why instead of writing normal of the person, you can change it to write the weight of the person. Don't need to write so many things. So yeah, usually in college, in matriculation, we just write the weight of the person. Usually in everywhere, usually we just straight away write the weight of the person. Okay, so that will be a complete free body diagram for the forces. Now, because this is chapter 8, you're talking about rigid body, the position where you apply the force is important as well. That's why you need to label the forces, the distance of the forces. Okay, to label the distance of the forces, what we usually do is we identify the pivot. Okay, in this case, we can think that the pivot is here. Okay, it's visible for us to call a pivot here. So if the pivot is here, then our length, we usually measure it with respect to the pivot. So you can do something like this. Then you can label this. You can label this. Yeah, basically that's enough already. Okay, they tell you that this is 1/4 of the length of the plank. You know that the wood, the weight of the wood from here to here is half of length because it's at the center, right? If this is half, then here is half at the middle. Okay, so in that case, if this is half, this is 1/4. If this is half, this is 1/4. Then what you're left with over here is just 1/4L. Okay, so that's it. That's a free body diagram for this situation. Make sure the first thing you do is you represent the object with a line, or if it's a pulley, then it's a circle. Depends on the shape of the object. Then you ask yourself the 5 questions, then slowly add on forces at the specific position of the object itself. Okay, so after drawing this thing, let's look at some of the examples you have drawn for your homework. Well, this one seems fine. So you have your weight, then you have your weight number 2, which is a person. I'll prefer if you can write 1 is for the wooden plank, just to make it very clear what does it mean. Then the second is probably for the person. Then normal, yeah, everything looks fine. Don't really need this arrow, okay? Don't really need this. The length measurement, it's fine. Okay, you can just represent this whole bar here with a straight line. Representing this whole bar here as a straight line is enough. Okay, don't need to draw it as a proper bar. Okay, the next thing, this one, yes, what's the problem for this one? They label the W here, but they didn't really label what weight is this. M stands for what? I'm not sure. Okay, so if you can label it clearly, that would be better. Then the next thing is the measurements. What is the measurements? Okay, next thing, this is interesting. You have your weight here, and no, the weight shouldn't be here because it's a uniform rigid body. If it's a uniform rigid body, the weight should come out from the center of mass. Should come out from the center. Weight should be at center. Okay. Then the second thing that I notice is for here you have N and you have weight. I'm not sure, but I see a few students that write it like this. I'm not sure why do they write like this. First thing is if you draw the free body diagram for the person, only there's normal force exerted by the plank on the human. Then this is the weight of the human. So this is the free body diagram for the human. What am I writing? For human. But if you focus on the wooden plank, then the wooden plank only has normal force exerted by the human on the wooden plank. If this is the plank, this is the human, the normal force exerted by the human on the plank will be downwards. And this downward normal force is equal to the weight of the human. That's why we label only one of it. We label the weight of the human, but we don't label the normal force. This is wrong. This normal force only exists in the free body diagram of the human because it's exerted by the plank on the human. This normal force shouldn't exist on the free body diagram of the plank because there is no upward normal force exerted by the human on the plank. The normal force exerted by the human is pushing downwards, and the magnitude is equal to the weight of the human. Okay, so the next thing is okay, so this one you have to be a bit careful. This one they make a few mistakes. A few mistakes here. First thing is the weight should be at the center. Then if this is your normal exerted by the pivot is not at the center. Pivot is somewhere around here. Then the weight of the people should be at the end of the bar. Okay, so important to be careful with the position. Okay, so how many more diagrams we have here, and also label the distance. Okay, there's still many. Probably stop here then. This one, this is complicated. Yes, this one is correct. You have weight of the wooden block. I won't call it be a cording wooden plank maybe. Then you have your weight of the person, but there's no weight C here. Okay, then this I'm not sure what is it. This I'm not sure what is it. Then the normal force is fine. You don't need to draw the human, that's okay. The pivot you don't need to draw as well. Okay, so last diagram. This one you forgot about the weight of the wooden plank itself. Or it's not that you forgot actually. You write it coming down from the pivot, but the pivot is off center. The weight should be coming out from the center, not from the pivot. Okay, pivot is just a place where there is normal force. I mean, for this case, it's the place where you have normal force. Nothing special about pivot. Weight come out from the center of mass of the object. Okay, so I think I will stop here for free body diagram number 1. Thank you very much.